Yo, yo, YouTube. All right, learning things. I don't think my last stream actually worked. So I'm trying this again. Maybe this will actually be a stream. All right, so I feel ridiculous. Learning. So yeah, to interview day 2, I am today I focused. I learned some React. I sat around and watched Pluralsight, learned about Next.js. Last time I used React, they didn't actually have Next.js, and I was complaining about how the framework of Angular is opinionated and it offers a lot of tooling that you have to kind of figure out on your own, and it can lead you down rabbit holes and paths of failure in React. And therefore I didn't like it so much as I did Angular, because it just had an out of box solution. Yes, it was a higher learning curve up front, but on the back end, when you're actually being pressured to deliver and do it right, and you're not having to worry about figuring out how to do things that should already be in there, like dependency injection or whatever. I don't remember if React had dependency injection back in 2015. Just an example, folks. Now, the other thing I was looking at is solid principles. Solid, SOLID. Solid, single responsibility principle. I'm going off my notes here. Software modules should have one and only one reason to change. Separation of concerns, high cohesion, how closely related different elements of a class are related to one another. So you want your class to have functions and properties that are highly related. If they're not, then you might want to split that class up into multiple classes. Single responsibility. Engine versus car body. Two different things. Maybe don't put them together in the same class. O of solid. Open, closed. Software entities, classes, modules, functions should be open for extension, closed for modification. I like to think of the decorator pattern. It's one of my favorite patterns that I actually don't use that often, but I love the idea of it. You start with some base class, you give it the functionality that it needs, and you stop. If you need to add more stuff later, then derive a new class from your base and add new functions to that class. Sort of the basic idea of the decorator. Your code's less likely to break. You're not constantly modifying single files. You don't have God object Sandy pattern or a class that has 10,000 lines in it, and it just keeps growing every time you need to touch the code. I've never seen that, I promise. Open close principle. That's pretty much open for extension, closed for modification. Liskov substitution, the L in solid, the principle, Liskov substitution principle. Subtypes should be substitutable for their base types. The common example is the square and the rectangle. A square may derive from a rectangle because they are similar, but a square has a special trait that the length or the length and the width are the same, whereas a rectangle, they can be different. So one fix might be to define your rectangle as a special case, your square as a special case of a rectangle, where the length and the width are the same. So you can say rectangle true in that one case. Or you can just do something else, like have a square class that's not derived from rectangle, and it's just completely independent. Problems you can have, though, is if you cast between them. If your square becomes a rectangle again, and you have some property of a rectangle that multiplies, and it's expecting those to be different, then your calculations might be off. You can write an example to prove that. I'm not going to do that. Let's see, interface segregation principle. The I in Solid, those are clients should not be forced to depend on methods that they do not use. Prefer small, cohesive interfaces to large, fat interfaces. This makes me think of WCF. You have proxy classes, and a lot of times they might have not implemented, not implemented, not implemented, not implemented. It's a headache to look at, to read, to ignore. Just not good. Something people may not commonly know is that interface doesn't necessarily mean, if you're a C# person like me, it doesn't necessarily mean the interface as defined in C#. It could mean it more generally means in the theory the consumer, the caller of your code. So if you have a class in an assembly and another class in that same assembly, and class 1 calls class 2, class 1's the consumer of class 2, and class 2 in that case is an interface in this theory. Now, do I go and break down my classes and think of them at that level as for the interfaces to make them super small? Not really, not in terms of interface segregation principle, but I do that sort of naturally with single responsibility. So I think they're going to be pretty close because of that. But who knows? I haven't gone and written an app that would analyze how accurate my thinking is. And then you have the D, dependency inversion principle in Solid. That one is high-level modules should not depend on low-level modules. Abstractions should not depend on details. Details should not depend on abstractions. I'm reading my notes here from previous study, previous job prep stuff, just refreshing myself. So this one is, think N-tier, 3-tier applications. You have the UI tier, the business logic tier, and the data model calling tier. Let's say your data model calls SQL. SQL has a SQL data reader in a list, and you return that to your business layer, and now your business layer has to figure out how the heck do I work with a SQL data reader to extract the data that I actually want. Well, that's where you're breaking dependency inversion principle if you're doing that, so don't do that. Return like a POCO, a C# POCO, or property bag, more generally speaking, to return that model. So the model has the data in it, on the list of said POCO data, and the business layer no longer has to be aware of SQL data reader. But yeah, the DI, dependency injection, use that instead of an explicit dependencies principle. That's another example that I have from my notes. So let's see. That's pretty much my day 2. Reading Solid, getting familiarizing myself with some React. I did look a little bit at Angular today, not a whole lot though. Right now I don't have anything in the bucket for an Angular job, and I'm already pretty familiar with Angular, so I'll probably review that last. That's about it, I think. Back at it tomorrow. I've still got several days where I can keep doing this, and I might come up with some fun stuff to do here. Maybe live. Might do a live deployment of to GitHub pages with my Angular app, building a static publish onto GitHub pages and do something fun. And then I might do the same thing with React. It sounds like a neat idea. Kind of compare the two, see how quick I can do it, especially since I'm good at Angular but rusty, and not at all up to date on React. About 10 years out of date. So that'd be interesting. All right, guys. See ya.